So this is Mahan Dadiria. This is an on-demand dynamic supplemental book on liquid formulation that makes learning faster, better, and easier. This book is categorized as liquid formulation as solution, suspension, and emulsions. These products are widely used in pharmaceutical and cosmetic industry. On introduction of liquid formulation. This is the third related video or submodule on unit of measurement and density. In this submodule, embedded videos are used extensively to help the reader visualize the concept without excessively using mathematical equations. Unit of measurement. Ingredient amounts are expressed in the unit, and two commonly used expressions in manufacturing of cosmetics and pharmaceuticals are weight and volume. Weight or mass is in kilogram, gram, milligram, micrograms, and volumes go in liter, milliliter, cubic centimeter, cc. That's also used, microliters. In scientific literature, moles and molar concentrations are also used. In addition, parts per million, gallons, pounds, etc. are also used. Unit of measurement for solid, that's weight. And solids are also used in manufacture and preparation of liquid products. Such as sugar is used as an excipient, sweetener in oral solutions. Amount of sugar or solid is generally measured by weight, and exact volume of the sugar solid is measurable gas methods. Here are the examples of powder, sugar, superfine, granulated, coarse, cube. And solids come in variety of physical forms. Powder solids' apparent volume may change upon tapping, but the weight will remain constant. And apparent volume is used to calculate bulk and tap densities of solids. We'll look at the video how that's done. So bulk and tap densities of powder are measured according to, in this case, British Pharmacopoeia, but United States Pharmacopoeia also has similar methods. Gently, about 100 grams is placed into a special cylinder. The simulation shows that. And once a volume is measured, then the material is weighed. The net weight of the material then is used to calculate bulk density. So in this case, weight is measured and the volume is known. The cylinder is then placed on a tap density machine, and pharmacopoeial methods require 1,250 taps. The tapping machine taps the cylinder as shown here. Once the tapping is complete, the volume of the tapped material is measured. Bulk density, tap densities are calculated by using equation density is equal to mass upon volume. The unit of measurement of liquid is volume. That's commonly used in laboratory method, and it's extremely important to remember and use volume as a measurement. Liquids are incompressible and they take shape of the container. So volume can be measured using calibrated containers, and many containers shown here such as pipettes, beakers, cylinders, flasks, droppers, they are commonly used and they are calibrated for the product. Shown here is a 1000 milliliter flask, and there is a meniscus that defines the volume. So it has to be carefully measured. In Beaker, this becomes slightly more difficult as calibrations have multiple graduation marks and the errors are plus or minus 5% as shown here. Whereas the error in measurement in graduated, calibrated flask is about 0.5% or less. So volume is extremely important. During manufacturing of liquid products, the volume is not accurately measurable during mixing, and it cannot be directly observed in a metal container, and this video will demonstrate that. So here we have a high shear mixer that's commonly used in manufacture of liquid products, and we'll start the video. And once we start the mixer, the liquid and solid that are embedded or solids that are there, they will start mixing. As you can see that there is no easy way to figure out how much liquid there is. This becomes even more difficult when we use stainless steel or a metal container. So unit of measurement of liquid in a manufacturing operations, especially large-scale manufacturing operation, is weight. Volume of liquid is very important. Measure for dosing, analytical methods, sizing of containers, etc. However, weight is a preferred method of measurement of liquid in manufacturing. This is because of accuracy and ease of measurement with load cells. And we'll show that in this video. So in this video, there is a mixer with 3 load cells. 1, 2, and 3. Each load cell is capable of measuring 500 kilograms. So total measurement is going to be 1500 kilo. This mixer is shown for a demonstration purposes. So one can see the mixing operation and the weight operation at the same time. Here's a mixer with a high shear mixer, and the weight control here is shown, and it has an accuracy of plus or minus 0.1 kilo. So 152.7 kilos is displaced with an accuracy of plus or minus 0.1 kilo. So once we mix it, you will see liquid moving, and we cannot measure the volume of the liquid, but the weight of the liquid on the load cell remains constant. And it will show 152.6 to 152.7 kilos. You can tare the weight to 0, and now you can add mass to it. In this case, 0.5 kilo is displaced as a tare weight, and this is very accurate for 1500 kilo max. This cannot be done by measurement of volume in production scale. So this is the advantage of load cells and weight measurement. So unit of measurement or concentration are required for formulation, for commercial manufacturing, and for the label on drug product. Solid ingredients in a liquid vehicle such as oral liquid, weight to volume is commonly used milligram of drug per milliliter. In manufacturing, we prefer weight to weight. How many grams of solid is added to how many grams of liquid product. Liquid ingredients in liquid media, common is volume to volume. In addition to that, weight to volumes are used. Weight to weight is preferred in manufacturing, and other designations such as units per volume are also used for dosing purposes. Solid ingredients in a solid media such as tablets, powders, that's weight to weight. Liquid ingredients in solid media such as water in granules are volume to weight and weight to weight. FDA regulations do not allow the strength of an active ingredient as a percent value for drug products. FDA regulations allow concentration of an amount of an active ingredient in an amount of solution. So we will see predominant labeling that's used in a drug product. Naproxen oral suspension shows 125 milligram per 5 ml weight to volume. Similarly, digoxin 0.05 milligram per ml, or each ml contains 50 microgram. Nystatin oral suspension has 100,000 unit per ml and also states alcohol content of 0.5% volume to volume. So alcohol content means 100 ml of product contains 0.5 ml of alcohol. Topical powder, in this case, that contains 1000 USP units per gram to solid, weight to weight. Different measures are used in drug labeling, and one has to understand its implications. Unit of measurement density relates mass and volume. Density is a physical property of matter. Density is given by equation D is equal to mass or weight divided by the volume of the material. Unit of densities are grams per ml, grams per cc, kilogram per liter. SI units are kilogram per meter cube. So density measurement is extremely important to convert weight to volume. Density of liquid, especially solution, is measured by pycnometer, and pycnometer is a calibrated measuring device, has an accurate known value of its exact volume. So pycnometer is filled with liquid and a capillary stopper is used so that we know it's completely full. And then it's equilibrated to the temperature where we want to measure the density. Generally for liquids will be about 20 to 30 degrees. We know the exact volume, so we can now weigh the pycnometer to measure the mass of that liquid or weight of the liquid. This is weighed. Density is calculated mass of the sample, mass of the air or empty pycnometer by exact volume plus the density of air for correction purposes in a production floor. Density is mass upon volume. So a beaker is weighed, exact volume of the liquid is poured into that beaker, and the mass of beaker and the liquid is then measured. Once the masses are known, we can calculate the density of the material by mass upon volume. So how do we use density to convert weight to weight, volume to volume, and all other parameters? That's extremely important in manufacturing world for liquid products. Density of materials can be measured as shown before, or that published literature in which densities are accurately given. So let's look at water. Density is mass upon volume. Therefore, the mass is equal to density times volume, and volume is equal to mass upon density. These three simple modifications are used to determine what's the volume, what's the weight of the material. So 1 gram of water, the volume of that is going to be 1 milliliter. Ethanol that has a density of 0.789, 1 milliliter of ethanol will weigh 0.789, and 1 gram of ethanol will have a volume of 1.267. Similarly, glycerol density is 1.26. That means 1 milliliter of glycerin weighs 1.26 gram, and 1 gram of glycerin measured as 0.794 milliliter. Similarly, reader can calculate the volume and the weight based on the density measurement shown here for mineral oil, polysorbate 80, polysorbate 20, both are surfactants commonly used in pharmaceutical and cosmetic industry, and sorbitol solution which has a density of 1.489. That means 1 milliliter of sorbitol will weigh 1.489 grams, and 1 gram of sorbitol will have a volume of 0.671 milliliter. So how do we now use these to get volume to volume, weight to volume, and weight to weight? So let's take two ingredients, sorbitol solution and ethanol, and these ingredients are provided in a different configurations. Sorbitol is provided at 25% weight to volume, and ethanol is 25% volume to volume in a product. And let's assume that product has a density of 1.03. So first thing is how many milliliter of sorbitol is in 100 milliliter of the product. It is 25 grams per 100 milliliter, this amount here. So convert 25 grams into milliliter, we divide that by density. Volume is mass divided by density. So we get value of 16.790 milliliter of sorbitol is in 100 milliliter of product. Ethanol is given as volume to volume. 25 milliliter of ethanol is in 100 ml. We want to now figure out what is the amount in gram per 100 milliliter. In this case, composition, sorbitol solution used in the product is 25% weight to volume. Ethanol 95% is used at 25% volume to volume in the product. That means it contains 25 milliliter with the density of 0.789. So mass is density times volume, So 25 ml will contain 19.725 grams per 100 milliliter. So now we are able to convert volume to volume into weight to volume, and in sorbitol, weight to volume into volume to volume. So in order to calculate amount of grams per 100 grams weight to weight, we need to know the density of the product. So 25 grams divided by 1.03 gives us 24.272. It is 24.272 grams of sorbitol is contained in 100 grams. So we are correcting by the factor of density. Similarly for ethanol, we have 19.725 grams in 100 ml. We are correcting that for the density of the product, 19.725 divided by 1.03. So we have 19.150 grams per 100 grams. So weight to weight is 24.272 and 19.150. So this is how we can convert weight to volume, volume to volume, and weight to weight by using densities of the material. This is extremely important in large-scale manufacturing, where we want to manufacture using weight to weight, and we still need to know the volume of the material. And extremely important also for the dosing, where we want to measure either volume to volume or weight to volume basis.